Alright folks, vertical versus horizontal asymptotes. Before we touch on asymptotes, let's talk about what are asymptotes. Asymptotes are basically lines on a graph that your function will never cross. Okay? Lines on the graph that your functions will never cross. Now when we see vertical asymptotes and horizontal asymptotes, just by looking at the words alone, we may confuse ourselves. Oh, vertical is y, horizontal is x. Well, in this case, that's not the case. Why do I say that? Remember, asymptotes are lines that graphs will never touch. So for a vertical asymptote, what does that mean? That is that my graph will never touch this vertical line. Okay? And if you actually look at the graph right now, it passes through a certain x value and y value is always changing. But it will never touch this line where x equals to a certain constant. Okay? Because it's a straight line down and your y is ever changing. So x have to be a constant. And then for horizontal, on the other hand, let's just draw a horizontal line. Wait, just to visualize it better. Okay. It's basically a line that your graph will never touch. And in this case, x is always changing, x is always changing. But your y stays constant. So in this case, horizontal asymptote is where your y is a constant. So now that we have established the understanding of vertical and horizontal, let's try to find these asymptotes. We're going to start with vertical first because it's very simple. So a vertical asymptote is when your x, let me just draw the graph again actually, is when your x never touch this certain, or when your graph never touch this certain line at a certain x value. Okay, so I'm just going to draw this line and I'm just going to draw a really ugly graph. Okay, it will never touch. And what happened when these two never touch is somewhat displaying the same properties as parallel lines, am I right? And parallel lines, what can we say about them? They will keep going on and on and on and on and on forever, but they will never ever cross path. So that means that my x can go all the way to infinity. Okay? Sorry, my y can go all the way to infinity because it's always changing. And then, the y keep going up and up and up. So it can never go to infinity. So how do I essentially make y go into infinity? Is when I take a certain function, divide by 0. It's undefined because it's going to infinity. So I cannot define it. Which is why when you are finding vertical asymptotes, where x equals to a certain constant and x will always be a certain constant, you just have to take the denominator equals to 0. So now let's just assume that the denominator is gx. So what that means is gx equals to 0. So if you look at our quiz, this was the denominator, 3x squared plus x minus 2. This is a denominator. So we just need to factorize this. And I believe it is a minus. And then we have a x plus 1. And then there you have it, your x value. Equal to minus 1. So for vertical, we just need to make sure that you just use your denominator equals to 0 and then you solve for it. To prove to you, is this it? Hey yo. Why you seem kind of straight, bro? Hold on. Hey, what the hell? What the heck? Why are you so straight? Something's wrong. Am I blind? Oh, I think I screwed up too much. Hold on, let me... There we go. Alright. Sorry, I'm a little bit excited. So there you have it. When x equals to -1, notice... Okay, I'm going to just... So as you can see, I'm going to use a red line for this. When x equals to -1, you can see that the line is not touching. And then what's the other one? When x equals to 2/3. 2/3 is about 2.6. Is it? Is this 2.6? No, 2.6 around here. So it's not touching at all. Right? So these are asymptotes. Vertical asymptote. Now let's move on to horizontal asymptotes. Actually, you don't really need to memorize the 3 cases. Let me explain to you the 3 cases. Right? The very first case is when your... Okay, same thing, I'm going to do fx. Okay, maybe I'll use a different color because Christian always use a different color and people like it. So the very first case is when your greatest coefficient of x over greatest coefficient of x, I'm not gonna write it out, I'm too lazy, of x and g respectively. When this is smaller, let's mute for 8 hours. Okay, so what does this mean? This one example can be x over x squared, x squared over x to the power 4, x3 to... You get the idea. Okay, so what happens when the top is smaller than the bottom? Obviously you can't divide the top by the bottom, right? You just essentially give you a fraction. Like for example 3 over 12, it's still 1 over 4, you still get a fraction. Alright, so in this case your horizontal equals to 0. Why? Because it all comes down to this one equation that ties all 3 cases together. And this is what the teacher went through, but it wasn't that obvious. I just found out about it like on the way bus home. So it's basically equals to, like, remember when you take this over this, then you get like this function plus your remainder divided by gx. Do you remember this? So what do you say? I forgot, but I'm just gonna write quotient, whatever. I just write qx. Okay, I just write qx. So it all comes down to this equation. So let's go back to the first case. So for the first case, I have, for example, x divided by x cubed. Because I cannot simplify this anymore, or I cannot divide x by x cubed. So essentially, I cannot equate this. So what does this mean? This means that this now equals to this. Am I right to say that? So this is now essentially this. And what we can say for this is as x goes to infinity, because it will never meet the line. Remember the concept about the parallel lines? Yeah. So because the 2 lines will never meet, x will just go all the way to infinity. And when x go all the way to infinity, this whole term, I don't know what's a good color, this whole term equals to 0. It becomes a very insignificant value. Okay, so it is essentially 0. So we can always ignore this part, but for our working we have to input this part. Okay, but we can always ignore this part for the final answer. So back to like what I was saying, maybe I'll use orange. Because we cannot find qx, what does this mean? This means that qx equals to 0. There you have it, my first case. Y equals to 0. This is my first case. Right? Second case is when both the coefficients are of the same coefficient. What does that mean? X squared over x squared. Okay, maybe I do a plus 1. X cubed plus x plus 1 over x cubed plus x squared. Okay, it doesn't matter. My greatest coefficient is the same. Let's do long division. Okay, let's make life simple. Let's use the very first equation. Okay, but before that, let's just rewrite this thing. I'm sorry if I'm speaking a bit too fast. I'm just going to put R for remainder. Okay. So when this divide by this, let's do the math, shall we? Okay, maybe I don't need to do so long. So x squared divided by x squared plus 1. X squared, I can do a 1. Alright? So 1 times x squared, 1 times 1, minus, it becomes minus 1. So this equation, so I'm just going to write it out, x squared over x squared plus 1 equals to 1 plus, my remainder is minus 1 over x squared plus 1. Okay, because I cannot divide this anymore by x squared. So this is my horizontal asymptote. Alright, to reinforce this knowledge, oh, I didn't mean to print screen. To reinforce this knowledge, okay, let's put a 2 over here. Okay, let's make life a lot more fun. Okay, actually, let's put a 2. You know, you guys will be very confused. Okay, so same thing, 2x squared divided by 2x. Oh, 2. Okay, 2 times 2x plus 2 minus 2. So same thing, my equation now becomes 2 plus minus 2 over x squared plus 1. And then you notice that my y equals to 2. So what does this mean? This is for the second case where when the coefficients are the same, you basically just take the coefficient of these two. So it's 2 divided by 1 equals to 2. So even if, let's say for example, I didn't mean to print screen again. I shouldn't have made the zik sound, I'm sorry. So even if, for example, I do 3x squared over 4x squared, okay, plus 2. For the sake of you guys, I'm going to show you that it is always the same. Okay, maybe I shouldn't use red. It's a bit too much for everyone. So this is just what? 3 over 4. 3 over 4. So what is 3 over 4 times 4? It's just 3. Then what is 3 over 4 times 2? Is 6 over 4. Minus, I get minus 6 over 4. Notice how I'm still getting 3 over 4. So my y is 3 over 4. See? 3 over 4. So this is a second case. So actually, if you think about it, right, you just need to keep applying this same formula. You just need to keep applying this same formula for for horizontal, and you always get your result. It's just that the first and second case is a very simplified version, and I'm just using the equation to prove to you why it can be so simplified. Now come to the last case. So the last case is when basically your fx is bigger than your gx. So in this case, it's like, let's say for example, x squared plus 1 over 2x. X cubed plus 1 over 2x. X to the power of 4 plus x over x2. Right? Is when your coefficient of your numerator is bigger than your denominator. Now in this case, it's somewhat logical that, for example, if I were to do this, right, okay, essentially I'm just saying that y equals to x. And how does a y equals x graph look like? It's going to travel diagonally. So what does that mean? That means that the moment when my fx is bigger than my gx, I won't get a flat straight line. Okay, I'm going to repeat. The moment when my fx is bigger than my gx, my line will never be flat. It's going to be slanted. Okay? And because it's going to be slanted, we have to say that there is no horizontal asymptote. Instead, these asymptotes will now become oblique. Oblique. I'm not good with words, okay? I'm not good with words. So I'm just gonna use our quiz as one good example. Let me just copy down the thing. X cubed over 3x. I mean, I'm kind of lazy. I'm just going to do 2x, okay? I'm very lazy, okay? How long have we been recording? 17 minutes, okay. So in this case, same thing. I'm going to do the long division. Alright, so what can we equate from this? 1/3 x, I believe. Yep. So it becomes, it becomes x squared minus 2/3 x minus, so it's just 2/3 x. And because I cannot divide anymore, because this is a 2 and then this is a 1, you definitely cannot. It's a lot smaller, unless this is like 0/2, then you can divide. But in this case, this is a 1, so you cannot divide. So in this case, my answer equals to this whole thing. Okay, so it's just this plus input the remainder divided by your gx, which is in this case 3x minus 2. But remember, because this will ultimately become 0, y equals to this. There you have it. This is your slant. So this is oblique. And I have just proved to you why this one equation works for all the cases, or rather this one equation allows you to find all the cases for horizontal asymptotes. It's just that the first two cases are pretty more straightforward.